Good day, everyone. And once again, we're back together, still looking at functions. And today, I just thought maybe we'll be concluding this section and body of work. However, we will revisit it, as we look at past exam papers in future. All right, so if you haven't subscribed, please just make sure that you're part of the family, and please hit that notification bell as well, okay? And for those of you who might need assistance, whether in mathematics or physical science, please, you're welcome to contact us. And our email address is info@mlungisinkosi.co.za. And please don't forget to share and like and, tell as many people as you can about our channel. All right, so today I wanted to look at equations that have to do with, finding the equation of a parabola. When you're given, points. All right, so let's start with the first question. It says, find the equation of a parabola that cuts through the x-axis at 2 and minus 3 and y-axis at 3, okay? So now, let's try to look at that quickly. So this parabola, first of all, you've got two x-intercepts, okay? And our x-intercepts are 2 and minus 3. So what I'm going to do, what happens at the x-axis, at the x-intercepts rather, we know this is where x is, a certain number and y is 0, right? So now I'm going to say, well, this is y is equals to a, okay? Now note, I'm going to open up my brackets. I know that one of the solutions is x minus 2. Look at that. I'm changing the sign when I put it inside the bracket. And the other one is x plus 3. So those are actually my my x-axis. Right, and remember that this is where y is equal to 0. Okay, so we can work out what's inside the bracket. So this is going to be, right, if we take that, this is going to be x squared, x times 3, that's 3x minus 2x. Okay, so that's going to be plus 3x minus 2x minus 6. Okay, right, let's simplify that even further. So that's going to be ax squared. Okay, so if I add these two, these are like terms, I'll get positive x, but I'm going to multiply it by a. So that's plus ax, okay, minus 6a. All right, and please remember all of this is equal to 0. All right, so in this case, I can actually make this my first equation. Okay, and then now the question is, how do I solve for a? Okay, so I can, how do I solve for the value of a? So now I can simply say, but what else are we given? We were given the fact that it cuts through the y-axis at 3. Now remember what happens at the y-axis. We know that at the y-intercept, okay, this is where x is equal to 0, okay? So in this case, I can actually substitute the point 0 and 3, okay? So it means that everywhere I see x on our equation 1, I am going to put the point 0, and where I see y, I'm going to put 3. Right, so in this case, I've got 3. Okay, so I'm substituting into equation 1. Okay, so substitute that into equation 1. All right, so in this case, I've got 3. Okay, I'm substituting for y there. Okay, is equals to a. Now x is 0, so that's going to be 0 squared plus a times 0 minus 6a. Okay, so what do I end up with? I end up with minus 6a, because all of the others are 0, is equal to 3. And so that means that I can divide both sides by negative 6. Okay, and ultimately I get that a is equal to negative 1 over 2. 3 divided by 6 will give us a half. Okay, so that's negative. So now what that simply means is that I need to go back to my original, okay, substitute for a there in the first equation so that I get the actual equation. So a is minus a half, okay, into, now you remember, in fact, yeah, okay, let's say minus a half x squared. All right, let me just remove that quickly. Okay, so that's going to be minus a half x squared. Let's get that away. Minus a half x squared. And then plus ax. So that's minus a half x. And then minus 6 times a half. So that's minus 6 times negative a half. Okay, so we write down the whole equation. So that's going to be minus a half x squared minus 1 over 2x, and 6 multiplied by half will give us 3. And it makes sense because they did say that the y-intercept is 3 and 0. And so that is the equation of our parabola. So that is how you would tackle such a question. I want us to take another one quickly, all right, so that you get familiar with this stuff. All right, so looking at example 2, right, so they say find the equation of the parabola with turning points 3 and minus 2 and cutting the y-axis at 16. Now, remember the standard form of a parabola. Okay, so the standard form will always be y is equal to ax squared plus bx plus c. So these kind of questions usually just pop up in the exam. And, you know, we should know how to find the value of a, b, and c. So now the first thing that I'm going to do, it's easier to just first substitute the y-intercept. Remember, so in this case, what happens at the y-intercept? This is where x is 0 and y is 16, right? So in this case, I'm going to substitute that into that original equation. So it means everywhere I see y, I'm going to substitute 16, and where I see x, I'm going to substitute 0. Okay, so this is going to be 16 is equals to a 0 squared plus b times 0 plus c. So that already automatically tells you that c is actually equal to 16. If you remember what I said in the previous videos, remember that when we know the y-intercept, we already know the value of c in this particular format. Okay, I will actually, maybe I'll show you another format of how we could have tackled this. Okay, so again, so now I'm going to be looking for, so let's actually write it down in full now. So we know it's y is equals to ax squared plus bx plus 16. Okay, so one of two ways in which we can solve it. We can actually just say, all right, now have a look at this. We know that at the axis of symmetry, if you remember, if I'm looking for the x value of the turning point, we know we always say minus b over 2a. Okay, so now I can say, well, I know this is minus b over 2a, but what is my my b value? Okay, my b value is still minus b and over 2a. In fact, here am I repeating myself. But what I'm trying to show you is that, remember, what is our x, the turning point? They told me the x value of the turning point is 3. Okay, so the x value of the turning point is that value over there. So meaning minus b over 2a should be equal to 3. So we can try and, simplify that. So minus b, okay, so if we cross multiply, that's 3 over 1. So this would be minus b is equal to 6a. Okay, so or you can say b is equals to minus 6a. Right, so if you want to, you can call that equation 1 or whatever it is that you wanted to call it. Okay, so now we at least know the relationship between B and A. So now we can use the entire point, substitute the entire point into our equation. Okay, so I'm going to now, in fact, maybe we should have called this equation 1 and we call this equation 2. So I am going to substitute the point 3, I think, and minus 2, is it? Yeah, 3 and minus 2 into equation 1. Into equation 1. So that means that we're going to take that equation. So this is where y is minus 2. A into x is 3. So that's 3 squared plus b times 3 plus 16. Right. And of course, what we're going to do is try and simplify that. So that's going to be 9a plus 3b plus 16 is equal to a negative 2. Right. So now to try and get rid of one of the, okay, you can call this equation, okay, maybe let's just simplify it even further. If I take 16 over to the other side, okay, so if I take 16 over to this side, it becomes negative 16. So I will get minus 18 is equal to 9a plus 3b. If you note there, you can actually simplify it further by dividing by 3. Of course, it will make things much, much easier. Okay, so in fact, let's do exactly that. So divide every term by 3. Okay. But remember, what I do on the left, I have to do on the right. So in this case, I'm going to have 3a plus b. Okay, remember 18 divided by 3, that will give us 6. Okay, so in this case, call that equation, so we had already called that equation 2, we called that, our equation 2 is that other one, yeah. So this will be equation 3. Okay. All right. Let me just remove that 2 there. Right. So that will be equation 3. So now, how can we solve equation 3? So in this case, remember we already have an expression that relates, okay, B and A. So I can substitute equation 2 into equation 3. Can you see that? So whenever I see B, I'm going to substitute minus 6a. So let's substitute equation 2 into equation 3. Okay, so this is going to be minus 6. Negative 6 is 3a plus, remember where I see B, I'm going to substitute now minus 6a. So in this case, that's minus 6a. And all that's left for us to do is just to solve. So got 2 like terms there. So that's negative 3a. It's equal to negative 6. So we can divide both sides by negative 3. And of course, our a value in this case would be equal to 2. Okay, and now it means that we can find our b value. Our b value now, remember we said b is minus 6a. So this will be minus 6 times 2. And so it means that our b value will be negative 12. Okay, so that means that finally we can actually now find the equation. So y is equal to 2x squared, remember, plus bx, so that's minus 12x, okay, plus c, and in this case our c value was 16, if I remember correctly. All right, just go back, yeah, plus 16, so this is plus 16. And that is our parabola. That is how we would tackle that equation. All right, so we'll take just one last question that has to do with the mixed functions, and I think we'll wrap it up there. Okay, and we'll look at some more examples in the future, rather, more exam type questions in the future. Before I look at another example, actually, I wanted to show you an alternative way of solving for the very same thing. Now, if you remember, we were given turning points. Okay, we're given the turning point to be 3 and minus 2, and we're given the y-intercept to be 0 and 16. Okay, so another way, an alternative way, which, it would be up to you whether you find this easier. Now, if you remember, we've got another way of expressing a parabola. Do you remember this? Ax minus p squared plus q. And remember what I said, that the p and the q value actually show you the turning point. So what you could do, let me just choose another color, sorry. So this is going to be a into x. Now for p, that is the x value of the turning point. So this would be x minus 3 squared, and then for y that would be minus 2, which is the y value of the turning point, right? So what you can do here is to actually find the value of a. So all by substituting, in this particular case, the y-intercept, just substituting all the point that you have for that matter. Okay, so I know x is 0 when y is 16, so I'm going to just substitute that there. So a is 0 minus 3 all squared minus 2. Okay, so this would be a. Remember 0 minus 3, that would give us a negative 3 all squared. That would give us 9. Okay, so we would have 9a, or a times 9 minus 2 is equal to 16. I'm dragging this now. Of course, if we take this to the other side, take 2 to the other side, it will become positive. So in this case, you'll have 18 is equal to 9a. And if we divide both sides by 9, of course, we get the very same result, that a is equal to 2. So what you can do now is go back to the original equation. Y is equals to 2 into, now remember, that's the standard form that we chose. Okay, so 2 into x minus 3. Okay, minus 2 squared, right? So that's x minus 3 rather squared minus 2. And all that you can do is now try to work that out. Okay, so that means that this is going to be 2 into, so I'm just going to expand that bracket there. Remember, it means it's x minus 3 squared, but I'm going to show you quickly. So it means that this is x squared minus, remember, when we've got two brackets that are the same, you can say 3 times x minus 3 times x is minus 3x multiplied by 2, so that's minus 6x plus 9. Okay, and this is minus 2. And then all that you simply do, we're going to multiply 2 inside our bracket, so this is going to be 2x squared minus 12x plus 18 minus 2, and you can see how that we've got like terms there. So that will be 2x squared minus 12x plus 16. And that is how you tackle it. I really think this is much neater, compared to the first way that we worked it out. Okay, when you use just what you know in terms of parabolas. Okay, and that is how you'd get the value of a, b, and C. All right, quickly, just one last example, and we will be wrapping it up. All right, and this is our very last example. So what I'm going to do is I'm going to just talk about the questions as we go along. But first of all, what I wanted just to do is just have a general discussion around this question. So they've given us two graphs. By the way, I took this from the November 2020 exam. Yeah, for the National Senior Certificate, the NSC. All right, so they say the graph of f of x, so this means this is the parabola. So there you have it there, okay? And then you also have the graph of g of x, which is the straight line, okay? So just a couple of things that, you know, if I were you, I'd want to actually look at. When I look at this, probably I might need that c value there. I might need that a value. So we'll work everything out as we go along. Okay. And I'll go through the questions. Okay. And by the way, once you have that, you actually will be able to answer all the other questions. So let's just work out a few things and then we'll just answer the questions. All right. So first of all, how would we get the y-intercept there? Okay. You can see at C, both f and g meet at that point, but you can choose either of them. Okay, remember what happens at the y-intercept. We know that x is equal to 0. Okay, so I can use that for f of x. So f of 0 in that case would be equal to 1 over 2 times 0 plus 5 squared minus 8. Okay, and let's see. So we've got 5 squared, which is 25 minus 8. Okay, so in this case, that's going to be 12.5. Remember, this would be 25 over 2 minus 8. So in that case, we'd get a value of 4.5. Okay. Right, you can say 9 over 2 if you want to, but if you notice there, you already had the same value as well for g of x if you took that. In fact, I don't know why I didn't do that. I think it would have been easier to do that. Okay, so we've got 9 over 2. Okay, so this tells us that point there. So what I like doing is just labeling my point so that I wouldn't necessarily struggle. So I know that point C there would be where x is 0 and y is 9 over 2, or you can just simply say 4.5. Okay, and then going to the next one, that a value. Oh, quite easy to get the a value, because if you remember what I said about the turning point there, so that means that this would be the point minus 5, and you can tell it's on the negative side, and negative 8 as well. Okay, in fact, perhaps I should write them in a different color, but nonetheless. Okay, so that's negative 5 and negative 8. And obviously, because point D is along the axis of symmetry, it already tells you that the x-intercept, rather the x value at D, that m value, would be the same as the x value at A, because that's a vertical line. It's along the axis of symmetry. So in this case, it's along this line here. So it means that m is minus 5. Okay, but now how would we get the value of n? We would need to just substitute, because you can see the straight line passes along that point there. So what you can do is just get that value by substituting into the equation for g. So g of x, which is 1 over 2 times x plus 9 over 2. Okay, but now I'm looking for g of minus 5. Okay, which is equal to 1 over 2 into negative 5. Okay, plus 9 over 2. Okay, so in this case, what you would have is minus 5 over 2, okay, plus 9 over 2. And of course, I'm still going to tackle fractions with you at a point so that I can assist you with that. So that would give us 4 over 2, and so that would be 2. So it means that my points for m and n are minus 5 and 2 respectively. Okay, and then what else would I want? So let's see there. So I've got E. I don't know if we would need our our x intercepts, but in case we do, all right. And I'm not saying this should be your approach, but I'm just trying to show you how you would go about getting the different values there, and we'll just get to the questions right at the end. Okay, so if I wanted to find the x-intercepts there, I would take that equation, the original equation of f of x, and make it equal to 0. So remember, for your x-intercept, we know that y is equal to 0. So let's take that original equation. So f of x is, okay, so we said 1 over 2. So that's 1 over 2 into x plus 5, if I remember. X plus 5 squared minus 8. Okay, so now we know that would be equal to 0. Okay, I just wanted to verify this this equation. So now if I wanted to solve for this, remember this is equal to 0, so it means that 1 over 2 into x plus 5 all squared would now be equal to 8. So I took 8 to the other side, so I can actually multiply by 2 on both sides to get rid of that half there. So I've got x plus 5 all squared is equal to 16. Okay, so now I can take the square root on both sides, but remember, when I take the square root, it should be plus or minus, right? So that square root gets rid of the square, so I've got x plus 5 is equal to plus or minus 4. So in this case, it would mean that x plus 5 is equals to positive 4, or x plus 5 is equal to negative 4. So you can see x is equals to minus 1 here, or x would be equal to negative 9. So if I look at my original drawing, okay, so it means this value here would be negative 9, and the other one would be negative 1. Okay, and it makes sense that halfway between that would be at negative 5. Okay, so there we go. Right, now I want to quickly look at the questions that were given to me, and then we'll go back, and I can understand how difficult it is, because we'll keep having to go up and down, but in this case, let's try to answer the questions. Right, the first one, they said write down the coordinates of A. Okay, so where are the coordinates of A? We already found those coordinates. That's negative 5 and negative 8. Okay, you saw how I did that. Okay, and the second question said write down the range of f. Now remember, when we talk about the range, it's where the graph exists, okay, in the y. So in this case, our range is from negative 8 to infinity. So remember, it doesn't exist below negative 8. It starts from negative 8 and it goes all the way up till infinity. So our range in that case would be y should be greater or equal to negative 8. Or if you wanted to put it this way, y is an element of negative 8 till infinity. Okay, nothing wrong with that. Of course, negative 8 is included, okay, and infinity is excluded. That's why the round bracket. Okay, the next question, they said calculate the values of m and n. Okay, we did that already. Okay, we found minus 5 and 2. And please try these questions on your own so that you can be able to, master this. And then the next question, they said calculate the area of OCDE. Let's see, OCDE. So it's that. Okay, I'm going to highlight it in yellow. So this area here. Okay. If I look at that area, what I would have done, it looks like a trapezium, but what I would have done perhaps is just to break it down into two, shapes, which is that rectangle there. Now we already know the value here is 2, so that value should be 2 there. And I already know that this is 4.5, which is the y-intercept. Okay, that's 4.5. So let's start with this rectangle here. The length is from 0 to 5. Okay, so that's length times breadth. So that would be 0 to 5. And then the breadth, which is there, is 2. Okay, so you'd say 5 multiplied by 2. Of course, in this case, we're just looking for the area. So I'd say area would be the area of the rectangle, that's length times breadth, plus the one of the triangle, that's half base times height. Okay, so length times breadth would be 5 times 2. Okay, so I would say that's 5 multiplied by 2 plus half of my base for the triangle. Now I'm going to highlight the triangle in green. Okay, so it's this guy over here. All right, so my base of the triangle is still 5. Okay, but my height is from 2 to 4.5, so that's 2.5 in this case. So you'd say my base is 5 and my height is 2.5. And of course you can calculate that and get to the answer. All right, and then they said determine the equation of the inverse of g in the form y is equal to. So now we are looking for the inverse of the straight line, and I showed you how to calculate the inverse. All you do for the inverse of the straight line, and by the way, please just get yourself that question paper. Try to do it on your own, okay? And see if you get to the same answers as I do. So this is f of x. Y is equals to half x plus 9 over 2. And of course, if you're going to find the inverse, all you simply do is flip the x and the y. So it means you're going to say x is equal to half of y plus 9 over 2. And let's try and simplify that again to get it into standard form. So that means that this is going to be okay, let's try and get that. So this is going to be a half of y. Okay, if I take that to the other side, it becomes negative, is equal to x minus 9 over 2. Okay, right, now what do? I multiply everything by 2 to get rid of that half. Okay, so that means that we're going to multiply even that by 2. Okay, so that cancels that. So y is equal to 2x minus 9. So that means this now. Okay, so this is, g rather. G of minus 1. So the inverse of g, because that's what they asked for. Okay. So the inverse of g will be equal to 2x minus 9. And that's the equation. Okay. And then finally, they said, okay, so it should be a tangent. Okay. So I'm actually reading off from something here. I said if h of x is the inverse of g plus k, that is, it is a tangent to f, determine the coordinates of the points of contact of h and f. Okay, right, so they're saying essentially h of x is the tangent to this graph. Yeah, I think it would have been easier to just look at that. Now remember, what is a tangent, or rather what happens at the tangent? It's a line that touches the graph once. So they're saying that h of x is has the same gradient, okay, as the inverse, okay, but now it only touches f once, okay. So say if it was 2x, right? So in this case, but it touches the graph of f of x once, right? So they want us to find the equation thereof, okay. So now please just remember what happens at the tangent. We said this is a line that touches the graph once, okay. So now what we're simply going to do is, okay, let's find. So they said h of x is equal to g minus 1 of x plus k. So that means that we are going to have to find where the graph of f of x has a tangent of or rather has a gradient of 2, because the gradient of the inverse is 2. So in this case, I'm going to take the gradient, okay. So f of x, in fact, let's write f of x in standard form, okay. So so this is going to be half of x plus 5 squared minus 8. So I'm trying to not to drag this too far, okay. So so f of x in standard form would be so that would be a half of x squared plus 10x plus 25, okay, minus 8. So that would be half x squared plus 5x, okay. And in this case we have 25, that's yeah, so that would be plus 9 over 2, okay. If you remember, that was not 9 over 2, rather our y-intercept in that case, yes, it was actually 9 over 2, okay. So in that case, it would be plus 9 over 2, because you'd have 25 over 2 minus 8. So that would give us 4.5. So this is plus 9 over 2. Why am I writing that there? So plus 9 over 2. Okay. Right. Now, how would we find the, sorry, that's f of x. So the gradient where x is equal to 2. So in this case, I would simply say, okay, let's find the gradient of f of x, okay? And in this case, it would be, okay, so jump down, 2 times a half is 1. So that would be x plus 5, okay? But I want where the gradient is equal to 2. So in this case, it would mean this is x is equal to, if I take that to the other side, this would be at x is equal to -3, right? So in that case, what would be the y value where the gradient is 2? So now I can go back to my graph and say, okay, let's substitute x is equal to -3 into the original equation, okay? So f of -3 is equal to 1 over 2 times -3 squared plus 5 times -3. Please have a look at this question so that you know what your approach should be. Plus 9 over 2, which is 4.5. Okay, I don't have my calculator next to me. So that is going to be 9 over 2. Okay. Plus, or rather minus 15. Sorry about that. So that would be minus 15. Okay, and just verify if my answers are okay. So that would give us f of -3. So I have to calculate this from the top of my head. So 9/2 plus 9/2, that would give us 9. Minus 15, that would give us -6. Okay, so we know the point would be where the gradient is is 2 rather. That would be at the point where x is -3 and y is -6. Okay, so now we can go to the graph of h of x, and we can say, look, we are looking for h of x would be equal to 2x plus k, right? And we can now look for the value of x. Okay, so by substituting, -6 is 2 times -3 plus k, and we can get ourselves that k value there. So that would be -6. Actually, k would be equal to 0. Okay, you can verify if that is correct. Okay, and as a result, that means that it would be the graph h of x would simply be just 2x. Okay, right, and that is how the cookie crumbles. I know I rushed past this because I just didn't want the video to become too long. All right, and I'll see you guys next time. All right, and please don't forget to subscribe. I think I want to leave functions here. Of course, we'll look at some more questions in the near future. And yeah, don't forget to subscribe. Tell even more people about our channel. Tell them how much you are able to learn through many great lessons. All right, and as for me, for now, I'll see you guys next time. Sharp, sharp.